So here's a review for your 4.1 to 4.2 quiz. We're going to be solving quadratic equations by factoring and then also by completing the square. So we'll start off by factoring, and if you remember, I mentioned factoring is really usually the easiest way to solve a quadratic equation. So when possible, if you're not told to solve a specific way, you should go ahead and try to solve by factoring to start with. And so what we do in order to solve by factoring, we want to get everything to one side, or in other words, set the equation equal to 0. It's good to have it in descending order, so you have your squared term, and then your linear term, and then your constant term. And what we want to do is we want to factor this trinomial. So we'll put our parentheses here. We want to try factoring it. We want an x squared, so we know to get an x squared we need an x times x. We have a plus sign here, which means both of our signs inside these parentheses will be the same, and then we look over to the negative and realize they both need to be negative. So we have a negative, and then we're finding the factors of 56 that combine to be negative 15. Well, we have 1 and 56, 2 and 28, 4 and 14, and then 7 and 8. And we notice here that if we use 7 and 8, we'll get the product that we want. And we can check that really quick. We know that the x squared times the x squared will give us this. So really we need to check the outer. When we multiply those, that's negative 8x. And the inner here is negative 7x, which does combine to equal the 15x. So now we're just going to finish this. And so we have two things multiplying together equals 0. So either x minus 7 equals 0 or x minus 8 equals 0. And solving here, we add 7 to both sides. And we get x equals 7. Adding 8 to both sides here, we get x equals 8. So our answer is either x equals 7 or 8, and that means if we put 7 or 8 back into that original equation, it would make it true. Moving on to the second one here, the first thing we want to do again is set our equation equal to 0. Here it is not set equal to 0, so we're going to subtract 33 from both sides. And we get x squared plus 8x minus 33 is equal to 0. This is another nice one to factor because it's got a leading coefficient of 1 out front here. And so we're going to put our grouping here. And in order to get an x squared, we need an x and an x. In order to get a negative, we need a positive and a negative. And then we're thinking, what are the factors of negative 33 to give us 8? Well, there's not a lot of factors of 33, so 1 and 33 and 3 and 11, and we notice that 3 and 11 will subtract to give us 8. And so we want a positive 8, so we make our larger number positive and our smaller number negative. And we can check that this is 11x minus 8x does, minus 3x does give us that 8x. And now we can solve, so two things multiply together to equal 0, so one of them has to be 0, so either x plus 11 is equal to 0, or x minus 3 equals 0. And subtracting 11, we get x equals negative 11, or adding 3 to both sides on this one, you get x equals 3, and so we can write this as x equals negative 11 or 3. So that's factoring. If you need more review for factoring, you can look that up in your book, or I'm sure there's other videos you could watch. Now we want to look at completing the square. So I listed the steps here. There's a lot of steps, and you should be getting to know these steps. You're not going to have these in front of you during the quiz or test, so make sure you're knowing them. And they don't, maybe you can just think of short phrases for each one to remember what to do. But the more that you practice this, the more, or the better that you'll get. So I'll try to point out the steps as we go along. So here we have x squared equals 4x plus 8. We're told to solve by completing the square. Maybe if we weren't told that, we would try factoring first. But we're told to solve by completing the square. So the first thing that we're going to do is we're going to get all the terms with x on one side of the equal sign. So what we would want to do there is subtract 4x from both sides. And subtracting 4x from both sides gives us x squared minus 4x. I'm going to leave a gap here because we're going to have to add something else in there, is equal to 8. The next thing we do is we're going to, if necessary, factor out the coefficient of the quadratic term. Well, the coefficient's 1 of this term, so we don't need to factor anything out of there. So we don't need to do that step. That step's finished. Maybe we should just say that's, so we did this, that's already done, which means we don't have to do that. Now what we're going to do is we're going to take half the linear term, which is our negative 4x, take half of that and square it. So we're going to take half of negative 4, which is negative 2, and we're going to square that, and we're going to add that. So we squared it, and then we're going to add the number from step 3 in the inside the parentheses. Well, we don't have parentheses here because we didn't have to factor anything out of the original, of the quadratic. And making sure we add the number to both sides. So negative 2 squared is 4, so we're going to add 4 over here. We can skip this step because we didn't factor anything out. We're going to write the trinomial now as a perfect square, and what we do is we have something squared, and we know that is x minus 2 squared, and then on the right side we have 12. Did that, and now we're going to solve as necessary. This one's pretty straightforward for solving. There's nothing on the outside of our parentheses here, so we can take the square root of both sides, make sure we put plus or minus, and we get on the left side we have x minus 2 equals, on the right side we have the square root of 12, and we can add 2 to both sides. So add 2, and we get x equals 2 plus or minus root 12. So this is the correct answer, but it's actually not written in the correct form. So what we want to do is simplify the square root of 12. So if you remember simplifying square root of 12, we're thinking, is there a perfect square factor? So is there a perfect square that goes into 12? And there is. There's 4 goes into it. That's a perfect square. So what we do is we divide the square root of 12 into the square root of 4 times the square root of 3. And again, we use the square root of 4 because that is a perfect square. And then we simplify. Square root of 4 is 2 times root 3. And those are our 2 answers, because we can think of that as that's x, or x equals 2 plus 2 root 3, or 2 minus 2 root 3. Now we're going to do a completing the square that does have a leading coefficient here. Actually, there's a couple things with this one that are going to be a little different, or not different, but use more of these steps that we have written out here. So the first thing we want to do is to get the x terms on one side of the equal sign. So we're going to go ahead and add 12 to both sides, which gives us 2x squared minus 5x equals 12. So we did this. Now this next step says, if necessary, factor out the coefficient of the quadratic term. So we're going to factor out this 2, which factors out easily out of there, but this one maybe we would say does not factor easily out of negative 5. Many of you can probably think through this, but if it's a number that is not an easy common factor, divide the linear term by that. So this is really just going to be the negative 5 over what we were factoring out. And so we still have our x here. We're going to leave a gap, close the parentheses, and that's equal to 12. Now we're going to do, so we did this, now we're going to really do steps 3 and 4 kind of together, or it looks like they're going to end up being together. It says take half of the linear term by either dividing by 2 or multiplying by half. Well, when we're working with fractions, it's easier to multiply by half. So we're going to 5 times a half is 5/4. So we're multiplying that by a half. So we're going to add, and it's a negative. So negative 5/4 squared. Again, that was taking half of this linear term, taking half of that, which we multiplied by 2, or 1/2, sorry, and then squaring it. So we did that. We added the number inside the parentheses here, so we did this part, making sure you add the same number to both sides. So we need to add that to the other side. Well, negative 5/4 squared, if you multiply that out, let's do it down here, negative 5/4 squared. If you multiply it by itself, that's a negative times a negative is positive, so we get 25/16. So we added 25/16, but if we look over, so remember, if there was a number that was factored out of the two terms, multiply the squared number to it when adding to the other side. So we need to multiply our 25/4 times this 2 when we add it to the other side. So we're going to do 25/4 times 2. Sorry about that running into it. And so we have 2. Now we can write this as a perfect square. This is x minus 5/4 is equal to, and now we have some work to do here. We're going to do 12 plus 25/4 times 2. Well, this 25/4 times 2, we can think of this as over 1. This 2 reduces with a 4. So this is 25/2. In order to add 12 plus 25/2, let's do some more work over here. We're going to take 12 plus 25/2, which we need a common denominator, so we're going to multiply this by 2 over 2, which gives us 24/2 plus 25/2, which actually ends up being 49/2. So we had to do some work to the side there, and this is all of this, we add it together, and that's 49/2. So we did this, and now we're going to finish it by solving. Solve for x is necessary. You may have to divide both sides by a number that was divided in the, or that was factored in step 2. So we're going to have to divide by 2, although instead of dividing by 2, multiplying by half might be a better option. So multiplying by half, since we have fractions, and I should have mentioned that down there, you can multiply by the reciprocal instead of dividing. So this cancels here. Over on the right side, well, let's write this across. We have x minus 5/4 squared equals, multiplying that, 49 times 1 is 49, and 2 times 2 is 4. Now we want to solve for this, so we're going to take the square root of both sides. When we take the square root of both sides, we put plus or minus, and on the left side, these cancel. We get x minus 5/4. On the right side, this is a perfect square, the square root of 49 over 4. Remember, we can take the square root of the top over the square root of bottom. Well, square root of 49 is 7. Square root of 4 is 2. And now we'll go ahead and add 5/4 to both sides to solve for x which on the left side that gives us x. On the right side we have plus or minus 7/2 plus 5/4. Well, in order to add these we need a common denominator, so I'm going to multiply this by 2/2, which is really 14/4. And then remember, this is two problems we have here. We have, this is 14/4, so positive 14/4 plus 5/4. So 14 plus 5, we get 19/4. And then we want to do negative 14/4 plus 5. So negative 14/4 plus 5 is negative 9/4. And those are our two answers. And then here's our last example. So maybe I'll talk through these a little quicker since we've done this a few times. What we want to do is we want to get all the x terms on one side, which means we're going to subtract 7x from both sides. And that is 4x squared minus 7x equals, going to leave a gap, equals -2. We're going to factor out a 4 here because we want a coefficient of 1, so we factor out a 4. And we get x squared, and remember what we do is since 4 doesn't factor easily out of 7, we do that 7 over the 4 that we're factoring out. We'll leave a gap here, equals -2. Now we want to go ahead, so we've done this, we've factored. Now we're going to take half of this term, so half of -7/4. We'll do that down here at the bottom. -7/4 times a half is -7/8. So we're going to take plus -7/8 squared. Well, let's do that. -7/8 squared is 49/64. And so we added that inside the parentheses, but that is multiplied by this 4 on the outside. So we really want to add that 49/4, but multiplied by, sorry, not 49/4, 49/64, multiplied by 4, because we have to multiply it by this 4 out here. So let's go ahead and do some of this. We're going to take -2 plus 49/4 64 times 4. Well, 4 reduces with that. That goes in there 16 times. We can get a common denominator here, so multiply by 16 over 16, which gives us a -32 over 16 plus 49 over 16, which ends up equaling 17 over 16. And so over on the right side, doing all that adding, or multiplying and adding, we ended up getting 17/16. Over here, we're now, so we've done this, we've added it to both sides, and now we're going to write our trinomial as a perfect square. We still have this 4 out here. So we have 4x from there minus 7/8 squared. And now what we need to do is we need to solve. We're going to go ahead and get rid of this 4 by multiplying both sides by 1/4. On the left side, we're left with x minus 7/8 squared, because those cancel. On the right side, we have 17/64. And then we're going to need to take the square root of both sides, remembering to put a plus or minus. On the left side, the square root cancels with the squared, so we get x minus 7/8 equals plus or minus the square root of the top is just 17, but the square root of 64 is 8. And now we can add 7/8 to both sides to finish this off. And we get x is equal to, and I like to put the term with the square root second, so we're going to put 7/8 plus or minus the square root of 17/8. And this is a common denominator, so we can combine that, and we get 7 plus or minus the square root of 17 over 8. And that's our answer because we can't simplify that square root of 17. And so there is a review of solving quadratic equations by factoring and solving by completing the square.